All right, welcome back. Today we are looking at iteration two of this EverCraft kata that we've been working on, or I've been working through, playing around with, and this iteration is all about classes. So last time, so to give a recap, what we did was we picked up this EverCraft kata off the internets. You can see here where it is on the GitHubs. And we've gone through the requirements. We built out the entire first iteration, so let's call it the first feature. And after we got the first feature done, we realized that we have no Rodney did a funny thing, and he left some code completely and totally unchecked in. And as a result of unchecked in code, I did a rebase, and some code didn't compile, and I did a full stop and was like, hey, let's go ahead and put some build in place. So last time we put nuke build and GitHub Actions together, and we put that together on our public GitHub where this is being hosted. And let me see what state it's in now. I have no idea what state it's in. So, okay, it should be in a good state. So let's see if I can go to the terminal. I should be able to just do /build sh and run my build and verify that my code builds and my... Oh no, build fail. Oh no. Cannot add solution because we have two. Why do we have two? Okay, delete that one. Yeah, now will you do the thing with the magic and the stuff? I think you will. Yeah, you will. Perfect. So we've got some confirmation that where we left off the last time works. We've got tests are being skipped. We need to fix that. We need to fix that. We can fix that. But yeah. So now we got at least some understanding that our code is compiling. So let's go ahead and run our unit tests so that we at least know where we start off, and let's go ahead and get a branch going off of where we are. So we're in iteration class, so we'll just call it get checkout dash feature class, right? Okay. All right, that's the solution change that we made. Perfect. So we, at least at this point, know that everything is where we left it. So let's go look at the requirements that we're trying to satisfy. So in a previous iteration of this, we did what a character is, and this feature seems to be about classes. So classes that a character can have. So have is a composition relationship. So we don't want to do an inheritance thing here because it tells us right here that a character can have classes. So it's potential that they could have multiple. So you wouldn't be able to do that in C# with multiple inheritance. So you have to find some way to do that. So this will be some type of object composition. Not exactly sure what that's going to look like, but I've been playing around with a lot of object composition in the past couple of weeks because I'm finding that I really, really like object composition. And the more I make C# feel like functional programming, the more I want to try a real functional language. So I've been also like looking at F#. Shh, don't tell anybody. To see if I like it, because it's one of those things where it might have some value. So, all right. So the feature says characters have classes. So that's a many to many, but hopefully it'll be one to one. So as a player, I want a character to have a class that customizes its capabilities. So a character has a class. So let's see what code we've written up to this point. Added traits. What are traits? Okay. We did start some code last in a previous thing, and I don't think I published everything, so I think it got lost in the Twitch stream. But we do have a start point for some of this. So we started talking about this as this class base, and that we would have this I class, right? So we have this interface that we boiled down these requirements, and let's split this screen real quick, and let's move this out of the way for a moment. All right, so what this says here is that a character can have a class. So a character would have an I class potentially, and that thing ideas means it would have ways that it changes in hit points, right? So changes in attack and damage, increase range, critical range or damage. Increase critical range. I don't know what that means, but okay, whatever. Bonuses, penalties versus other classes. Special abilities and limitations. So okay, so the way I see that is, yeah, this is where we got into these traits. So we can adjust different traits, which I don't know if I like any of this anymore. So we may actually just scrap this and start fresh. As a matter of fact, we're going to do exactly that. We're going to go ahead and scrap that. And we're going to define what we think a class should be right now. Right? So like, it may end up being the exact same thing. We may get to the exact same place, but in my opinion, it's worth the exercise, at least for right now. So, it can do things like change changing hit points would be changing a character. Let's go pull the character class up. Let's close. Yeah, let's close all. And let's go to the Explorer real quick, and let's pull up our character. Right, so this is our character. Let's pin our character. Our character has abilities, right? Okay, so what we're saying here is this has the chance to change a character's ability, right? So we can change what their core ability is, right? Or we can modify it. Maybe we can't change it. Maybe this is a modify. Maybe we call this modify a character's ability, because it's really just a modifier because you have the class. If you didn't have the class, you wouldn't have it. So I don't think that it changes it. I think it just augments it. I guess augment is change, and we're talking like tomato, right? Modify and change, I guess, is the same thing. But I'm looking at it as a modifier, as it doesn't actually mutate the thing. It just modifies the thing. So yeah, I'm going to keep the word modify, because modify is a very specific term that says that it's going to modify the character's abilities. It's not actually going to change them. It can't mutate them. It can just modify them. So it's an extension. All right. So changes in attack damage. Again, that's just okay. So that's modify character attack damage. Attacks. Right, so maybe we have to send in a modifier to the attack, right? It could increase range, so that could just be a modifier on crit, right? Modify. So I'm looking at now, this is completely different than I think I was looking at it before. Modify. So we may have to create a concept of critical damage being its own thing, but I'm trying to avoid that. Bonuses, penalties versus other classes. Okay, so modify. Modify a character's ability. Ooh, if I could spell, that would be awesome. Ability. Or critical based on target's class. Class, right? Okay. And then it can provide. So now we can have. So now we've got the concept of class abilities and character abilities. So abilities, right? And limitations. So I'd call that like strengths and weaknesses, but they call it abilities and limitations. So let's use the language that the business uses to convey the information to us. So now we would have a concept of a fighter, right? So one of the first class that we would implement. Class would be a fighter. I know there's already one in here. Yep, here we go. So let's just go look at that. Let's actually just let's bypass the fighter because we've already got a fighter. Let's go to something else, and let's see if we can do something funner, mo better fun, right? Paladin. Self-righteous jerk is really not my bag. Oh, I can defeat my enemies with finesse. Finesse seems fun. Finesse, but a monk, right? Yeah, okay. We're sold. We're going to do the monk. Monk. So as a player, I want to play a monk so that I can enjoy being an Asian martial arts archetype in a medieval European setting. Wow. That's funny. Okay, so it's going to be a class, right? So we're going to have this I class. We're explicitly not going to take any dependencies on the interfaces, right, or on any base classes. Public, class, monk. Okay, we haven't put anything on this interface. So right now it's just a marker. Right? Okay, that's fine. So 6 hit points higher per level instead of 5. So let's just put in English that modify hit points. Wow. Hit points. +1 per level. Okay. So we have to have a way to say that when the leveling system does its calculation, that it knows that this thing gives a hit point change. Okay. And we want a consistent way for the API surface to be used, right? Because like this is a heterogeneous set of things, but I don't know if these all need to be properties on the class itself, or it could just be like a list of specific property type with information, or a heterogeneous list of information, right? Like that's what I'm looking at. So I'm trying to figure out it, like, and I think that's where I went before, and I'm just trying to see if I still want to go down that path, or if the path changes slightly based upon looking at a different model this time. So does 3 points of damage instead of 1 when successfully attacking. Ooh, I do more damage, so damage +2, right? So we're just going to have like a list of modifiers, and the modifiers are just going to apply during certain points. It seems like I'm oversimplifying it, but it also feels like I could easily overcomplicate this. I don't want to. Adds wisdom modifier if possible to armor class in addition to dexterity. So modify armor class plus wisdom modifier okay. And then my attack roll is increased by 1 every second and third level. What? Whoa. Brain just exploded. What? Attack roll is increased by 1 every second and third level. So are we saying any multiple of 2 or multiple of 3? I think I have to change that requirement slightly because like I don't think the business understands what they're asking. The business is asking me for something it doesn't understand. Wait. So okay, so let's do math here, numbers, right? So like that would be first level. So when I go from level 1 to level 2, it would increase by 1. Level 2 to level 3 would increase by 1. Level 3 to 4 would increase by 1. Level 4 to 5 it would increase. Second and third, like that just sounds weak because like I would need it to be mathematical in multiples of like every second or third because that's just it's kind of greasy. Kind of feels greasy. All right, we're not gonna worry about it. We're gonna just power through this and figure out how we want to handle this. So we'll just call this. Um, we'll split the diff. Every third level, he'll get 2. So attack, roll, modify attack roll, modify attack roll. So that means everything has to have an extension point for allowing for a modifier. So it means attack has to have an extension point to allow for a modifier. Um, oh no, the modifier comes directly off of the class, which would be baked into all of the stuff that the person does. So every time they create an attack, so it's almost like you would want an attack factory that you could take into the character, project the attack, create the attack. The attack would have all of the additional modifiers on it that it needs. It would have it because it would have access to the character, so we get all of the modifiers that it needs off one character and the other. It could do a modifier calculation for any explicit thing, but would it be that would the attack be the right place to do that? I guess it would because it's a superstructure around the two. Okay, so let's think about that again. So a character creates an attack. An attack has to be to a 1-to-1 map. So like a AOE attack or something like that, or like a multiple attack would be would be 2 attacks, right? So it would be attack on one person and another, which makes sense because his armor class doesn't affect your armor class unless his abilities give him the ability to affect your armor class, in which case we would have to take that into account, and that would be really, really difficult. So we'll figure that part out later. Because right now the character, I feel like the player should be the one rolling for the character. Jeez, let's not overcomplicate and overthink this. Modify attack roll +2. Okay, cool. So then let's go back to our character, right? So let's now actually build out Oh, we were doing that. We have test characters, don't we? Let's go create some test characters. This will be fun. Because not like we're just going to test our API surface anyway. So let's go ahead and go and create a directory and say directory class, because we want all of our class stuff to be in here. Add let's call him okay, so that's actually interesting. We're creating a class now. We wouldn't actually want to create we would want to create our own test character. That's fine. We still gotta put classes or tests in somewhere, so let's do that. Add class tests. Boom. Alright, so now we got some tests. Let's move this stuff out of the way. Let's actually pull this move monk. Because I wouldn't have like a named character type unless I was doing some really funky. I don't ever think I want to do that again. So yeah, let's not do that. Let's just go ahead and create a fixture and let's create a mock character. Let's just create some mock characters. That'd be great. Add class. Let's just call him All right, so he's going to, this is going to inherit from character, which means he's going to be all those things. He's going to have all those fun things. He's going to have a name. Or do we even have to do it that way? We can have fun. Can we do it? Yeah, let's see if we can do it that way. Instead of creating it as a yeah, we can still do public class. He would just, whatever. We could use the character builder to return it. And it could just be, it could be the result of a character fixture. So we could just do public static class, and then we could do in here, we could do character. Let's play with this real quick. Character, public, character, equals new character fixture, where I give him a name and I call him name of. Oh, let's actually just collapse some. Oof, this is too much stuff going on. I just realized that. So we want to keep that open because we want to be able to see that. I think we need to pin this tab, and let's pin that tab, and I may actually be violating some copyright laws here, so I need to, I don't know how it was spelled, so it's close enough. So I got a monk. And he's going to be of that type. So now we're going to have to give him a class, right? So we're going to do like a with class in order to give him a class. And we're going to call it new monk. I think that's probably all we need to give him at this point, right? So like now we have can I do that? I don't think I want to do it that way. That's fine. So we'll go here. With class, takes in an I class. I'm going to call this class. Next. Oh, let's actually call that character class. I actually probably should go back and change this to I character class, just because I don't want to conflict with the C# typing system for no other reason. Because I feel like in this domain, class would be a valid could be a valid name, but because of the C# typing system and the word class being a thing, I don't want to get into that fight and be fighting with that, for the remainder of this code base. So sometimes you have to make concessions, right? And that's like a concession that I'm willing to make. I don't want to fight with the C# typing system and the C# language features, so I know that they like class, so I can't use class. All right, so we give it a monk. So now he's a monk. Let's change this up a little bit. This I'm going to do. I think I'm going to make this thing. Is this the thing I want to make static? If I do that, now that'll still work. Cool. Okay, that'll still work. Great. So now I can just get to them. So now while I'm testing my class, I can do fun stuff. So now let's just go ahead and we've got class tests. Let's actually test each individual class because, Rodney's clicking buttons. Add class. Let's do monk tests, right? So that way tests. So that way we're keeping it separated. Fact. Add in my X unit. Oh wait, I've got a thing for that. X unit. Haha. Should. What should it do? We don't know. We don't know what it does, but we're gonna do monk system under test equals new monk, right? And we're just going to adhere to the stuff. System under test dot. So how do we? So now we got to figure out what behavior we're testing, right? So like, what behavior are we testing? We're testing that if we create a character that is of type monk. Yeah, we have to create a character of type monk. That character should have 6 hit points instead of 8. So let's go check the naming conventions of these tests, because I think, yeah, okay, I've been using the given when then syntax on there, right? So like given a monk, given monk, right? So I guess we don't need monk tests if we're doing it that way. So we don't even need given, right? We can just say when constructed even, right? By the time it's constructed, then character has 8 points, right? And we would expect, ooh, this is interesting. Now what we're saying is okay, I see what I'm doing here. Rodney's doing bad things. I'm trying to test integration stuff instead of looking at exactly what I'm going back to this. I need to project a modifier, a hit point modifier. So I need some indication when this monk class is created that the behavior that it will project onto a character is that it will modify those hit points once per level. So now I'm looking at these things as static abilities or static things. There we go. Yeah. And things that happen. Oop. We shouldn't have did that. We should not have done that. There we go. Pull it down. We're talking about things that are static, right? That happen regardless. These things up here. And then we're talking about this here. So this is an interesting concept, because now we have a thing. Okay, so now I'm seeing a pattern, right? We have a thing that is being modified and a thing that is modified. Oof. So public class modifier, right? It would take in, we're just going to use words, right? It would take in public modifier would have to take in some object thing that it's going to apply it's going to take in something and it's going to apply a func over that something. So it's truly just going to modify it, right? Like it's just going to say, give me your thing and then return your thing the way you gave it to me. That's going to be a per level thing. That's going to be a once every 3 levels thing. So that would denote that there would have to be some check as to whether or not we could actually execute the modifier. So, okay, so let's just do this. Okay, so we have the func. So the thing that we send in, or no, we could just do this like this. We could just, okay, a modifier. Maybe that's what it is. Maybe the modifier just has a public func of object. I don't know what these things would be. Object, right? So like it takes in something and it gives back something. And this would be how it modifies. So it's still awkward to express functions like this, because like I'm basically just giving you a function property. Okay, so it's a modifier, so it's a function that just modifies. So then we would have so we could really just make this an interface that could be extended down the line, so we could get some interface segregation magic going on, right? So like we could have a modifier that modifies. So then a class would just basically be a list of modifiers at that point. That's how we would define a class, as just a list of modifiers. Which gets back to, so now let's take a quick look back at what we were talking about before. No, yeah, let's go back and what we were talking about before were like traits and this like I trait thing that we were trying to get into. And we were trying to have like ability traits and attack traits and all of these different traits. And I have no idea. Yeah. And it was basically at the end of the day, just applying something anyway. So like, yeah, okay, we're getting into it. So now we don't need any of that ridiculousness. We can go back and define a very simple API surface. And we can basically just say public interface I modifier, right? I'm a modifier, and I have a public, I have a, no, I'm a modifier, okay? And this is how we get our polymorphic expanse. Okay, so here we go. So now we have like a damage modifier, so this would be like a public interface I damage modifier, right? And this would be an I modifier. And this would have a func of int, right? So it takes in an int and it passes back an int and it says modify, right? So I define some function. I think I'm gonna like this. I think I am gonna like this. Okay. So yeah, so I have a damage modifier. I would have here we go. Yeah, this is gonna be, I think this is gonna be better than what we had before. We have a I hit point modifier. We could have a hit point. Okay, we could have an attack modifier and an armor class modifier right now. So let's try that. And then after we build out this surface, then we're gonna go back and look at the fighter and see if this would still apply correctly across a different class, right? So we look at two different classes and see if two different classes can both conform to the same interfaces, then maybe we'll be okay. Oh goodness, my microphone is all in my face. So this would be an armor class modifier. It'd be an armor class modifier. It could be a hit point modifier. Hit point modifier. Oh, we had the hit point modifier. We have the armor class modifier. And we have the attack modifier. Yeah. Attack modifier. Okay. So right now it seems like all of these things actually are just ints. Like, let's go back and look at our class real quick and see if that matters. Our character real quick and see if any of that matters, right? Because those things are just things, right? So dexterity. So, okay, we could have one that does abilities, and abilities could be slightly different, right? Where it takes in an ability. Maybe the level needs to take in the level. Maybe the whole thing just needs to be a wrapper around the character, and it needs to take in a character. I think I like that, right? Because now the modifier is a thing on top of something. So a modifier would take in a character. Oh, T character. Can we, yeah, can you do the thing? Can you if you oh, you're not going to do the magic, okay. And let me just put the where clause on here and do this. Like, so now we're getting into C# generics, and I'm like, ooh, every time I start going into generics, I'm like, yay. No, we don't need the semicolon, doesn't belong there. The semicolon belongs here, where T character is of type character. Uh-oh, what is this I character? Character. Wah, 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 wah. Or T is of I character class. Okay. Oh, okay. Oh, so now we can even get into creating specific modifiers for specific classes. I actually might like this. Hold on. This is I character class, right? T. Oh, this is going to end up giving me that, whether I want it or not, T class, right? So now this would be T class. Wow, T class. And can we just, yeah, add the I character constraint? You are awesome, other than you just didn't format that the way I want to, which I'm sure is just a setting in Rider that I don't have set correctly. Boom. So now a modifier is going to be a modifier on a character and a class. I don't know if I like that just yet, because then we can just define, then we could actually just define something where it's like modify. And I think we're getting into strategy. This is where I'm like, I don't like this coupling, because like I could, before I was thinking I could very easily do a strategy to do some of this stuff, but now I'm like, I don't know if I can do that. T character. So we want to, yeah, so. So combat would take in a, or would these modifiers live on the? Okay, so now here's the question: do the modifiers actually live on the on the on the class, or does the class just reference? I guess it's the same thing, right? The class is referencing the things that it wants to use, so it would have its own set of modifiers that could be used at any given point. So we would pull out the specific modifier during the specific point in time that we need it, and then we would use it, and then it would be good. And now it's like the modify doesn't actually sound right, because like we're not modifying the character. We what are we trying to modify? Like what is this I class again? So character abilities. I actually do think that that's right, right? Because like we're not modifying the. If we have the full fidelity of the character, we can do modifiers. But see, no, we may even need to do modification. We may even need to do a modifier when we have two characters, right? So we need to know information about one character or another. So I feel like the modifier, any construct that we do modification, needs to have. It needs to be able to collect information about the character. That would be a single. This would be a single. This would be a damage modifier. So here we would still have to do like T class. Cause like I guess actually that's actually a good point. Do we need any of that? I think okay. So let's because I think this is about to tell me. It's gonna tell me to make it a covariant or contravariant. Is it contravariant? Yep, contravariant. Okay. New. I actually don't want that. I don't need that. I can just pass in anything that conforms to I character of class, and then I just have to do a modifier, and then modifiers, these would be class modifiers. So, okay, here we go. So this is an I class modifier. Boom. So now I'm creating a reusable, so this gives me the ability to later come back and do like character modifier if I want to, right? And again, I may get halfway down the road and find out that I really don't like this, and that's fine. But we got to start somewhere, and I think this is where I want to start. So let's. I need to persist your polymorphisms. I actually don't need that anymore, right? So like now all of this just becomes a big set of polymorphic junk and stuff. Will it complain? Okay, let's just make it as terse as possible for the moment, and let's just do that. So now we've got a hit point modifier, we've got a armor class modifier, we've got a attack modifier, and this is all at the class. This is interesting. So like now we're talking about like vertical slices, right? So like the vertical slice, in my opinion, would be modifiers. And then inside of modifiers, I would probably put class, right? Because that's the and then we could have like class and character modifiers. This may, again, we may end up finding out later that this is the completely wrong way to do it, but we're gonna start here. So like this would be class modifiers. So we could just create like a I class modifier thing here. Do like a I class modifier. Boom. It's not a class, but it doesn't matter. So I'm just gonna paste that thing over there. I character class modifier. Ooh, the verbosity. So now here we get to the point that I was trying to make. Okay, here we go. EverCraft needs to be renamed. Okay, you're smarter than me, Ryder. I know that. So now let's talk about like this namespace is modifiers class. So like, I don't really feel like I need this level of fidelity in there anymore. I feel like I can just get away with this. I really do, but that's only because I feel like that's going to be the thing. Uh-oh, what did I just do? Okay, undo modification. Yeah. Don't be silly. Don't do silly things. I just wanted to rename the file. There we go. Okay, so now we've got that. Let's go back over here and grab all this stuff. And then we're going to start playing with this and see if this actually does anything for us. Because like now we have an API surface. Let's come back here. Let's call this thing modifier. Because now I can do class dot damage modifier and do it that way as opposed to having it as fidelity in the name, and I kind of like that better. Yeah, these are modifiers. These are specifically class modifiers because I may have like, because to this point, right, I may do some type of generic public interface I modifier of T, right, where this thing does this. And maybe this API surface is probably going to change in a minute, but this would just be T thing. Interface modifier. Oh no, I guess we can't do that because of what? Make partial. We don't want to make it partial. And that doesn't make it any... Oh, that should make it more specific. So, okay, the naming would still matter. So, okay, I think I still would have to name it that way. Oof. But it doesn't matter because, like, it's the base. It's the base, right? apply name refactoring. This would then be this, 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 this. And then, oh, maybe because it was in the same namespace. Let's move all of these, move in file. So then if I took this modifier and moved it out here, just for crits and giggles, we're gonna see what happens. Yep, because then it readjusts the namespace, and now that is the modifier, that is the thing. This is now an open generic that we can make contravariant, and this is a constrained generic thing that could potentially now inherit from EverCraft.modifiers.modifier of T class. Yeah. That works for me, actually. Believe it or not. Because this is just this is actually probably going to be like in... Oh no. Oh no, what did we do wrong? What did we do wrong? Okay. 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 Alright, fine. I broke it. I broke it. Where did I break it? How did I break it? I modifier. This is the thing modifier. There's one inheritor, which is this modifier. Oh, now all these need to just be this. Yep. Because now it's generically constrained correctly. So now all of these... Nope, we want... Yeah, that one's fine. Yeah. Oh, we're going to rename it. That's why. That's an attack. And this is an armor class modifier. Okay, so now we have all of these different modifiers. They just take in a character and they modify. So now we can do like a... And we'll call this a single character... Single thing modifier. Single... Because we may have multiple later. We'll worry about that when we get there. Okay, so we actually haven't written much code yet, like and done much of a thing, rename file to match type. So let's go back to our tests, and let's just say that when the monk is created, right, a monk, because the class isn't really holding on to much information other than our what the modifiers are. So let's go back and grab this thing so we can get back to it and pin it. And then let's close everything else so we have a cleaner surface to look at. Okay, so we've got what our monk is basically just a list of modifiers, right? It has, So I can have like the standard modifiers, your 1, 2, like damage, armor, whatever, and then we can have the special ones in their own like special collections. So that way we have a standard set that are attached directly to the class, and then maybe like a more like the heterogeneous stuff that we want that would be... Why you know TDD? Oh my goodness, Chase. Florell has decided to grace us with his presence. Define what the API call should look like first, then implement. Yeah, I'm not implementing anything. Like I'm just looking at interfaces right now, and now we're about to get to the TDD. Like, notice I have tests. Oh, they went away. Where'd they go? Here we go. Monk tests. They were supposed to be up. I got tests. I'm just defining what I think the API surface should look like and making sure that it works out in my head before I go much further. True TDD sometimes can be too much, but like now that I have a thought in my head of what this looks like, now I can play with it. So getting to Chase's point, Chase is like, well, Rodney, why don't you just test it out? Well, the problem is that I can test out the behavior of the class, but how the class works on the character is really the API friction that I'm more concerned about. So to his point, should I just jump in and start testing that surface? Well, I can jump in and start testing that surface, but I don't know what this thing looks like. So what should this thing look like? And reading the requirements, what it looks like this class basically is just... Yeah, this class is basically just a list of modifiers, right? So You can modify hit points, you can modify attacks, you can modify crit, you can modify, other things. You have special abilities. So maybe the special abilities spike the API service via tests. Oh yeah. Well, that's exactly what we're going to do, Chase. Yep, that is a great point. We are going to verify that our API surface at least looks correct based upon a test. So the first thing we got to do is create a failing test. So the first thing we want to do is be able to say, when I create a monk, we expect a monk. Oh my goodness, why does this README always jump to the bottom? It does this every single stream and it drives me nuts. Okay, when a monk should have a thing that says that when you level, but see, this is where it's like the integration is weird. So it should just have a hit point modifier that when you call it, it gives you the hit points +1. We are actually passing in, so this is where it gets fun, right? We are actually passing in a character to our modifier, so we can actually test that our modifier can check all of that information. So this is why I think this is a good API service, but we might actually end up in like a two-way fiasco. But what we'll do is we'll say it should have a system under test given. So when it's constructed, right? Then the system under test should have a hit point modifier, right? System under test should have a hit point modifier, right? So every class will have a basic set of modifiers, special abilities, and limitations, and we'll call those things separate, and we'll explicitly call out what modifiers we allow, and then in the future, if we need more, we'll expand, or we'll figure out if we need to step back and punt when we get there. So we already see that, it's there, but then the question, do we want an explicit modifier? Do we just want a list of modifiers that we can get out by type? I feel like that just becomes a list of modifiers, right? And we go say modifiers, and it contains a single, so like we'd have system under test that has modifiers. Yeah, I think I like that better. And then it would be like dot should dot contain single x is I hit point modifier of type monk. That's what I would expect it to look like. So, okay. So now this is just going to be an I enumerable of I modifier of monk, right? Because we know everything in there should be a monk modifier. Uh-oh. Missing import. Okay, it's just imports. So now we can say that all of the modifiers would be there, right? And that would just be a list of modifiers. So now what we're saying, yep, now this comes in, we've imported our thing, and we're actually just going to go ahead and run our test. To Chase's point, we are going to now use our API surface. Yes, we know you know more than I do, Ryder, and that I'm clicking buttons that I shouldn't be clicking. Let's actually do all of these class tests in a new session so we can just focus on that session today. Hey, we've got failing code, let alone failing tests. Errors. All the stuff we did the last time, that was a whole bunch of code. See, this is why this is exactly why Chase is challenging me to do what he's talking about. Last time we started this exercise, I wrote a whole bunch of code, a whole bunch of interfaces, and a whole bunch of base classes, and never really wrote any tests, and wasn't really happy with the way this stinking thing looked. Like, it just looked like, it was like, this is just way too much, right? So now, yeah, that's fine. I think that's fine the way I'm doing that. But yeah, here, so now like I wrote all of this classes and traits and I tried to boil everything down to one thing, and it's just like, no, let the things be the things that they are, man. Let them be what they're going to be. So this is classes, so we don't need any of this class-based stuff. So we're going to delete it. We're probably going to delete the fighter no, we did say we were going to go back and look at the fighter and see if the fighter works out the way we expect it to. Right? So we will go back and look at that after we write a couple of tests just to verify that, at least what we have works and the way that we're going is working. So we'll do system under tests, dot contains, terseness is a thing, readability is king, and we'll run the tests. We don't have any errors now, we just have warnings. Uh-oh, it does not contain the thing. So let's go make sure that this thing contains the stuff. So a monk, when we create a monk, when it's constructed, right? Because we said when it's constructed is what the test is testing. So we're going to have modifiers, and it's going to equal a new... We're just going to be extremely greasy, and we're going to do a... And we don't have an implementation, right? So we'd have to do a new... This is going to be a monk hit point modifier. Or... Okay, so we're gonna use it. We're gonna do something that we're probably gonna regret later, but we're gonna do it anyway, just because we want to see how it feels. Public class, and we're gonna just call this hit point modifier, right? Because we have to define, like the way we've got it set up now is we have to define these modifiers on the class anyway. So why not just do that, and then we can do new hit point modifier, and then just define it. I think I like that, right? Because now I can have hit point modifier. This is going to tell me it can be private. Yep, it's going to tell me it can be private, and I think that's correct because it conforms to the Oh no, this has to be an I hit point modifier interface. Yeah, buddy. Does it have to do both? Oh. Let's... Ooh. Okay, that means that this is actually just going to end up being a marker. This is just going to end up being a marker interface. This is not going to have anything on it. Let's take that off because we don't want to implement that right now because that doesn't get us where we want to be. This gets us where we want to be. This thing modifies and it takes in the... Yeah, I think we're going to like this. I think we're going to like this because now when we run our test, it will have a thing that is of type I hit point modifier, which is the public interface. We have a private class that we can now keep close to our monk. So now our monk is going to be all self-contained monk logic. I think I like this. Okay, so now we have a thing. So now we can also say that we can do another XUnit test, right? So let's run another test. And let's say hit point modifier. Okay, so wait, okay, so no, given a monk, when hit point modifier applied, when hit point modifier called, I guess it's called, yeah. Then should return modifier, right? So, but see, okay, so this is where this is going to get weird in my mind, and this is where I'm going to be like, I want this to be composable at a different level because even yeah, I feel like I'm not getting the object composition that I want, but this is fine. This is exactly why we're doing this, right? Because this gives us the ability to test that surface. That gives us the ability to test the surface. So we'll do system under test dot modifiers dot dot select x is hit point modifier. So actually, we may actually want to go back and make that up something else, but introduce variable, we don't actually want to select it. We want this to be the first because we expect it to be there, right? Like we've got a test that says it's supposed to be there. So we're going to go get the thing out. We're going to do var modifier, which I think actually in this case is our system under test, yeah? Now we're just testing modifiers. And we want to give it a This is where the inception comes in, and my brain is going to start hurting. So let's just keep going. And let's see how this looks. I can already see where this goes. Then we'd have modifier, which is probably really going to be our system or actually it's really just the thing we're asserting. It doesn't have to be our system under test. So no, here we're going to do modifier dot modify monitor. What is that? That is a I modifier of. Oh, it's result. Oh. Oh, I see. Is so dot cast. Is cast not a thing? Okay. Now I see why I want to do the select. So let's do dot select. No, let's do dot where. Oof, this is gonna get ugly. X is I hit point modifier of monk, and we may actually go change and just create an actual explicit interface for it. Dot select that as of type. Somebody was just telling me about that the other day and telling me I should use that. Good. So now this is a modifier. And we're going to do modifier dot modify. We're going to pass in Yatsu dot character. What is this? Surface one and wants an I character of a specific class. Arg. Do I have my composition reversed? Do I want it to be that the class has a... No. The character has a class. Let's keep going. So this just need... Okay, so then we can just create a class of type monk. And this is I character class, which this is so what I need to do is create a specific character type. I need to do public class monk character, and that would be the implementation of I character of so we have the monk class, and that would be a monk, right? And that would be the thing that we implement, and that would also just be of type character, and then we would do that. Yeah. Okay. It's generated in the base. We're not going to deal with that. Okay, so then monk, then this guy would have to be of that type. And then we'd have to create a monk character for that. This is already turning in more code than I want it to be. Oh no. Let's do public, or let's do internal class monk character fixture. One second, folks. Apologies, my wife came in and was asking me for some assistance, and I like to keep my house happy, so when my wife needs help, I help her. We'll just do a new monk character. It needs... Okay, so this is gonna... Ooh. Feel like I'm doing a whole bunch of nonsense right now, but whatever. I'm gonna take all of this. I'm literally just gonna grab all this, and I'll worry about the inheritance stack later. Boop, doo, character, monk, build. We're gonna do a monk character fixture because I don't want to play with the inheritance stack if this overall thing is not gonna work the way I want it to work anyway. I just want to see if this will get me where I want to be. Monk. Oh wait, no, we don't need that build. And this build would be underscore die roller, underscore roller, underscore ability factory, right? Okay, so that gets me, and then this would just need to inherit from I test fixture builder. I test fixture builder. There we go. Okay, now everybody's happy. Except for this test over here, which is still like, hey, how do we do the thing? So now we're going to do a new monk. So, okay, Gyatso, we can send in Gyatso's character, and what we're going to say is this is going to be the var result, and we're saying that the result should be 1, right? So when we send in a character, the modifier that we get, and this is where it gets weird, right? Because, like, if the modifier already has fidelity to the character, why do I need to send in the character? So this is where, like, API surface and what Chase is talking about when he says just verify the API surface. Like, I may get into this and find out that the API surface is ugly and that I don't like it, and that I may need to take a step back and punt, right? But the unit tests will help me prove that based upon how it's being consumed. So now we've at least got a test that tells us that when the monk starts, that whenever you pass in the thing... And see, that's the thing. Okay, so now that we know that this is a monk hit point modifier, we don't actually even need to take in the monk in order to give you the modifier. We know for a fact... Yeah, see, Chase is right. See, this is why we like having friends around. Because we don't need any fidelity off the character. I am a monk hit point modifier. I behave a very specific way. And the inheritor of that, we don't need the monk. Right, so let's go here. And this is where it gets fun, right? Like, what we were trying to do is create a consistent API surface. And that's why we wanted the character here. Because then we can inject the character when we create the modifier. And then just have the character there if we need fidelity onto the character. So we would... that gets into a very ugly thing that I don't like to do, that we'd be newing up these modifiers based upon the actual character. So like we'd have to do like a this instantiation type thing, which I don't like to do. I don't know that I want half of this right now anyway. So let's just keep going and see. We already know that we don't like this. So we know that we don't like this. This is bad. But this is actually going to return... Oh, this is always going to return 1. Right? This is always going to return 1. Based upon the requirements, right? The requirements say that when my monk... Oh no, it's going to do it per level. So it's only going to do that when I level. So when I level... Okay, so let's go back to the character, because the character actually comprises the majority of the leveling system right now, I think. Or the leveling system exists... Yeah, experience. So I think the leveling system exists within the character right now. We may end up pulling that out. Yeah, because the character has a level, and the leveling happens as a result. He would this would actually, okay, so this would actually be a class character. Which could still inherit from character and get all of the chocolatey goodness there. Let's make that abstract. That's still going to tell me that it needs that. And now if I go back, everything should be good except monk. What am I doing? Oh, I no longer need that. That's inferred now, I think. It looks like it. It looks like it's inferred because I don't have any errors. So yeah, now that would be inferred because it would be an I character of monk. So okay, so that's fine. So it still fits that type definition. So all that's still good. So we're gonna give him a name. He's gonna be of type monk. When we give it a class, the class needs knowledge of the character in order to do its modifications. The modifiers need access to, and we're trying not to inject it, so like that's why we were passing it in here, but like it seems like this hit point modifier should only be called when the character levels. So let's go write a test for that and see what that looks like. Chase is right. We need to write a unit test for that and see how that feels when we actually go to apply the thing. And we may find out that we need that now we need a leveling service, but this should now just return 1. That's green, and I think that we have a false positive here going on, folks. So let's dig in a little bit more. Oh, it's already 3 o'clock. We're probably going to break here soon and see if we can get some food. So this is actually way more difficult than I wanted it to be. Or maybe I'm just complicating it more than it has to be. We're doing a monk, right? So the 6 hit points per level instead of 5. So, okay. So we're doing cross. So I think we still can do it in the monk tests, right? Because this is still in the realm of a monk. This would probably be more of an integration test, but I'm not going to mince words today. I'm just gonna test things. So let's go to our class. We've got our monk tests, and we're just gonna create a new test, and we're gonna say we're gonna test the behavior that's in the requirement. So whether it's an integration test or a unit test is moot to us. As behavior-driven developers, we are testing the behaviors that the business puts in front of us because that's what they're going to ask us. The business is not going to come back and ask us, oh, did you write a test that tests that API surface or that class or that private function? No, the business is going to come back to you and ask, hey, Rodney, how does that thing work? When I give you this thing and this other thing happens, what would be the result? Like, that's what they're going to ask you. Hey, when I tap on the button, what's supposed to happen? They're not going to ask you whether or not the class has test coverage. They're going to ask you that behavior. What does that behavior do? So we like to test behaviors. So we're going to say given a monk. So given, we've given a monk when level up, then hit points increase, right? And we can say that we know that the hit points should. So now we can go ahead and say we have a level 1 monk. So our Gyatso will be our level 1 monk. So we'll say, what does it take to make Gyatso level up? Character dot. Okay, so let's go back to our other tests that show us how the experience system works. So we have a new experience, inline data, increase, decrease, test base. Oh, we just put this right in here. Like we are just doing all the bad things and none of the good stuff in our testing surface. We are not testing that, are we? Are we doing character tests do we have any tests that verify that? Oh, I'm embarrassed to say I don't know if I have tests that verify that session. So let's say we have a character when experience gained. Okay, so we do have an entire set of tests around when experience is gained. So we should gain a level. So we should be able to just increase the experience to a point where they level, and then after we increase their experience, okay, so right now he should be a level 1, so we should be able to do character dot experience dot increase. Seems good, by 100, I think it takes. So let's do 1001, just so that we verify that it does anything. And then we'll say that, just to verify for the moment, we'll say that gyatso dot character dot experience, or wait, no, dot level dot should be 2, just to verify that our stuff is working the way we expect it to be, right? So we'll go ahead and go back to our other session, and we'll say when gyatso levels up, yay, things work. So now what we're going to say is that so now that we know that his level works, right, that he levels up, we're going to say that the character dot hit points dot should be, oh, wait, let's talk about that. Okay. Has 6 hit points per level instead of 1. So I think that starts with 1, right? That starts at the first modifier. So really we don't even need to do this, but we'll say that when he levels, he should have 12 hit points instead of the normal 10, because we should be able to apply the hit point modifier. So we'll go ahead and run the test again, and it should fail, and now we can go verify this API surface is trash like we think it is. So let's go verify our trashy API surface. So we'll just put the given win here because we know. In the inner workings of the character, we're going to have some really ridiculous stuff going on. So let's get the terseness that Rodney likes. And of course, like this entire thing is just setting up the ability for us to be able to go through and do the magic. So like we're excited about that. Yeah, we may actually be able to end up modifying the character right there, but we may not want to. So let's figure that out, if we want to modify the character's state or not. But we need to go to our character class because that's where all the magic happens. So, but we have a monk character now. So our monk character could do its own modification here and potentially override this default stuff. So now this is where it gets fun, right? We're doing stuff based upon property change, and we're doing hit points stuff here. But really, what we should potentially be doing is calling the level up method, right? And in the level up method, any given character can do what it needs to do. Okay, so let's make that modification real quick. And then I think I'm going to take my leave and cut it a little bit short today because I need food. But this proves that we have a problem, right? Because we can do a win any value change, but now we would have to modify this, and we would have to do ridiculous stuff in our base class, and that violates the open close principle because like this is now has to be modified as opposed to extended. So what we actually want to do, I think, is we want to do a .invoke command, and we want to do a this character level up, right? We want to explicitly want to level up, right? So we'll create a reactive command. We won't make it base. It will take in an integer. I guess it technically doesn't even take in anything because we're not using that. So it could just be unit. Right? Like you leveled up. If we later determine that we need to take in the level to... Oh, wait. We know we're going to have to take in the level, right? We know we're going to need... And we want this to be... okay, yeah. We know we're going to need to take in the level. So let's just take in the level. And let's just go ahead and project the unit out because we don't care about what the return type is. We just want to project completion. And then we'll go ahead and do that. And in that level up method, the default thing... Okay, so now we need to define this. So we're going to define our reactive command dot create what are we creating? We are creating a method called execute level up. That is going to be a private void method where we do I think we're going to give you a list of modification points here. And make it so that you can't call the level up method directly, but will allow you to modify hit points, right? Hit points, I think is going to be camel case, right? We're going to allow you to modify your hit points. You're going to be able to modify, I don't know what else you're going to need to modify, but whatever else you're going to need to modify is all going to be done right here as a result of you leveling up. We're going to take in the int level, which will give us the ability to determine what we need. This is going to take in the level to determine whether or not it has what it needs. Come on, you can click the buttons. So now we're just going to change this real quick. We're going to create a method. We're going to call this modify. We're going to make this protected. We're going to make it virtual. And now we've given you an extension point that you, or actually we're going to, do we want to make this abstract? Yeah, we want to make this abstract because we want everything that does the thing. Oh, wait, but the class isn't abstract, so bleh, let's not do that because then we're going to cause more problems than we want to deal with today. So right now, that'll just do that thing. This is still complaining to me. Hey, I got a spin wheel. Beautiful. Let's go ahead and do this, put that there. Oop, yep, there we go. And then we'll take those two things and we'll kill that. And we'll put this stuff at the bottom of the class where we think it belongs. All right, so now any inheritor can inherit from it and do the thing. I've got a subscribe in here we need to get rid of. So this is going to be, I think this is going to be the default. Right? I think that's exactly what we do, right? Yeah, here we go. So this is the default for that. And then you can override the default if you want to. And that'll be the default for hit points, right? We will modify the hit points. And if you don't override us, this is how we will modify. So now what we'll say is that our monk, which I think that's fine. So now I've got this monk character, and we've got this character class. So now we should be able to just do override, modify hit points. Yeah, I love it when API surfaces come together. Ooh. Oh, it didn't do it that time. Yay, it stayed right where I wanted it to. So now we have special abilities. As a player, I want a character to have a class that customizes it. So hit points, fighter, monk, 6 per level instead of 5, so yay, we still have it on our, okay, so we'll do that. We'll do the, we done broke it. We need to make this protected set now. Is this private and we don't have access to it? Make default hit points protected. Yep, because we weren't planning on inheriting from it, I think, at first. So now we have the level. I think this works for me because then we can just say default hit points +1 because we know that it has a +1 modifier, and we should be able to just run this now. We don't have any errors. Let's run the code and get some feedback. Thought it was going to be 12, but found it to be 5. Okay, so let's go back and run all of our tests and see what's breaking. Because we may have broken everything with this, you know. We aren't perfect. Oh, we have 2 broken tests. Look at that. Hit points don't increase. So we expect the system to test hit points to be... so, okay, so it's not getting called anymore, which means that our invoke command is not working correctly. So how can we go fix our invoke command? When property value changes, we can invoke command, this target command. So I know exactly what this is, and this is already going to aggravate me. So I'm learning this, and I thought that this used to work, but maybe it doesn't. But I'm going to put this thing above the place where it's defined and run this test again and verify that this works. And then I'm going to be mad when it does. Yep. So this expression body is supposed to give us deferred execution, but for whatever reason it's not. So the whole purpose for using this particular overload is moot. Like, that overload is supposed to give us the ability to not have to create that up front and be able to come back and defer that till later. It's not working, so whatever. Now that should be... It's still gonna fail because it's gonna 11 instead of... so how do we give... So that means that we would have to override the way we set the hit points. Protected set. So here we could just... Okay, so here we could just set hit points in the construct. Okay, so let's go to the monk class, back to our monk class, character class, our monk character. And names are hard, so we can come back and figure out whether or not this polymorphic stuff is causing more problems than it's actually solving later, because it may be, but it may be the right way to do it for us to get the proper like bridging that we're going to need for the future. So who knows? We will figure that out as things come. But we can, okay, here we can do, and now I'm going to get into why I didn't like to do that way in the first place. Here we go. Hit points equals 6 to start with, right? That's the starting for a monk, is just going to be 6. Yep, there we go. So now what we've done, hey, I think we'll call this entire session successful as a result of this. What we've done is we've changed the way our leveling system happens, right? Our character now levels up, and we've given you the ability to, through polymorphism and through, various strategies and template methoding, we've given you the ability to execute the level up command, right? Which encapsulates some level of logic. It encapsulates it in the domain itself, right? And it's going to execute a level up method which you, the consumer, don't have the ability to change, but we give you these template methods that allow you to say, hey, if you need to modify the hit points differently, you go ahead and override the way that works in your implementation. But if you don't, this is the base way that we consider all characters will level up hit points. We've also given you the ability to go ahead and override the default hit points by making this protected. I think this actually probably needs to be protected set as well. Set just for crits and giggles. Doesn't seem like we're setting it anywhere, so that's good. So maybe it doesn't even need to be set. Maybe this could just become a 2 property, and that would be awesome. Less mutations, the better. So this gives me promise that the approach that we're trying to take is going to be satisfactory for what we're trying to do. Yeah. So we are going to come back to this API surface in the very near future and verify whether or not we actually think that this is going to continue to give us lift. But for today, I'm going to consider this entire session a success. I'm actually going to move this entire thing in here. I'm going to clean up some of this code probably off camera, but this will get pushed up and it probably won't be changed much other than I'll probably clean up some namespaces and clean up some of these warnings in this file, because warnings in files drive me nuts. Thank you for joining in, Chase. Thanks for your comment on the TDD. When we first started this entire thing, we said we are going to try and take a test-driven approach, or more importantly, a behavior-driven approach. So to Chase's point, we have proven that the behaviors work. We have proven that the API surface is actually very relatively minimum, right? The consumer of the API surface needs to do no more at this point than just instantiate a monk, a given monk character, right? And give it and then when that monk character increases, it should have the correct number of hit points, right? So we're using a behavior driven approach by defining the behaviors in a test, testing out the surface, and then implementing the behavior to make sure that the behavior works based upon our API surface. So I'm probably going to clean up some of this stuff. So like this, I don't want this to now be a hit point modifier for monks, right? Like this is all probably going to become internal stuff. And I'm going to create like a monk modifier and all that stuff directly in here. But like because I'm already doing that with classes, I don't feel like I need to do that with interfaces, but it may clean up the surface, right? To where in the monk bits or let's see where the usages are, right? Because maybe we don't want to do that. Maybe that will cause more problems than it fixes. Because we're only really using it in tests to get it out, so we'll see. But anyway, we've taken a test-driven approach. We've proven that that we can at least satisfy the initial requirement of doing certain things in certain ways. So it's been a good stream, I think. I think I'm going to call this a success. Next time we'll come back. We'll finish off implementing the monk based upon the way we have it, and then we'll go back and start looking at the fighter and see if there is, because these may have different things that may have completely different concerns, and we may want to figure that out. So until next time, folks, thank you for joining in.